All right, continuing with the real estate agent, comparing size and selling price of homes, we saw that there was a strong positive linear association among those things. So we could draw a line there, but where would we draw the line? I mean, knowing how to draw the line of best fit kind of gets a little hard sometimes. So we're going to take the same data and we have some lines of best fit or some lines drawn in. And notice that on each of these lines, they drew in how far away the line was from each of the points. So on this side, these little vertical distances between the point and that line are very small. And on this one, they're pretty large. The line that fits the best is the line for which the sum of the squared distances is as small as possible. It's called the least squares regression line. Now we're going to look at two ways to find this line. The first way is by hand. And so given ordered pairs X and Y with our sample means, the mean of the X's, the mean of the Y's, standard deviation of the X's, and standard deviation of the Y's. And if we know the correlation coefficient, the equation of the least squares regression line for predicting Y is written as so. And they tend to write it in the form where the Y-intercept is B sub 0 and B sub 1 is the slope. And so we have this nice formula for finding the slope and a formula for finding the Y-intercept. Now, the variable we want to predict in this case, the seller's price, is called the outcome variable or response variable. I like the word response. And the variable we're given is called the explanatory. Or you can call it the predictor. In the equation of the least squares regression line, X represents the explanatory and Y represents the outcome or the response. So let's compute this line by hand. Then we'll do it in the calculator and see how close we got. So when we have these in our L1 and L2, I can go to Stat, Calc, and this time I have two variables. So I'm going to click on number 2, and well, I better do it up here, 2 var stats. And the things I want, the things I need, I'm going to need, let's go ahead and run it and we'll pick out what we need. 2 variable stats. I need the X bar is 2891.25. I also need the standard deviation of the X's. That's 269.49. And I also need the average of the Y's, the mean of the Y's, and the standard deviation of the Y's. So I'm going to scroll down a little bit more, and there it is. I'll go 3 decimal places on both of those. Now, with that data and with our R value that we had found previously, which I'm going to write it a few more decimal places. It was 0.9, but technically it's 0059. We can find the equation. And on some of the homework problems, they actually give you all of this information and ask you to find the line. So I'm looking up there and my slope is what they call B1, and that is R times the standard deviation of Y over the standard deviation of X. So I'm going to do 0.90059 times the standard deviation of Y divided by the standard deviation of X. Now think about that. Change in Y, change in X. And I get 0.099, basically 2. Now my y-intercept is represented as B sub 0. And it's y bar minus B1 x bar. So it's this average of the y's minus my slope times the average of the x's. That's my y-intercept. So 447 minus 0.0992 times 2891.25. And we get 160.188. Now, this is not going to be the same as when we actually run it because we're rounding here and there. But our equation, and they tend to put this little y with a hat on it. That means the approximate value of y, or my estimated y, because it's not going to be the exact value, right? It's just an estimation of y. It's a prediction of y is going to equal my y-intercept plus my slope times the x value. And this is the form you're going to see on most of the homework. So let's go ahead and write it by hand, then we'll do it in the calculator as well. So the y-intercept plus the slope was 0.0992x. Now, in the calculator, we ran this linear regression yesterday. I'm going to choose this 8th option because if I look at this equation, it has the x at the end. So I'm going to use this 8th option. Now, on your homework, it may change. Sometimes it may have the one with the x first, and you would choose 4. But let's see how close we got. It says A is 160.19. Whoa, we're close. And the B is 0.09919. Oh, we are right there. And it also gives me my R again. Now in the NumWorks calculator, and I'm using my calculator, so I don't have to keep flashing back and forth. Under regression, you'll see at the bottom of the screen from the graph, whoa, trying to get it to zoom in, 0.09 gives me my A. This one gives the slope first, then the y-intercept. It says AX plus B. So it gives it to you there. And if I go to stats, it also gives me my standard deviations. And it gives me my A and my B for my regression line there as well. And your R and everything in the stats column too. So you can get it in both places. Now here's the instructions on doing the linear regression and which one to pick. And now let's talk about that predicted value. We can use the least squared regression line to predict the value of the outcome variable by substituting a value for the explanatory variable. So if we have this equation line and we want to predict the selling price of a house of size 2,800, then we'd plug in 2,800 for X. So we plug it in for X. Now, one thing I do like about this calculator, when I'm on the graph, if I click OK, whoops, I'm so sorry. This has got this bad glare on it. It says the prediction given X or prediction given Y. It'll plug in, I can type in any X value, and it gives me my projected Y right there. And I know you can't see it very good. It says it's 437.948. Use the equation to estimate the average price for all houses whose size is 3,000. Well, we'd plug in X is 3,000. And it says the predicted Y is 457.788. So that would be the estimated price. Now, interpreting our Y-intercept and our slope, let's talk about that. So the Y-intercept is the point where the line of best fit or whatever would cross the Y-axis. This has a practical interpretation only when the data contains both positive and negative values of X. If the data contains both positive and negative values, then the Y-intercept is the estimated outcome when the value of the explanatory variable X is 0. If the X values are all positive or all negative, then we really don't have a useful interpretation. And also you need to think about it in terms of your situation. If we have our Y-intercept here, that would mean when X is 0. And what is our X in this problem? It was the house size. So we're talking about when the house is 0 square feet. Would that make sense? No. So that would not be a good interpretation. Now, interpreting the slope, if the X values of 2 points on a line differ by 1, their Y values will differ by an amount equal to the slope of the line. So we can use that to find things. So if the values of the explanatory variable for two individuals differ by 1, the predicted values differ by our slope, B1. If the values of the explanatory variable differ by an amount D, then we would just multiply that by the slope. So two houses are up for sale. One house is 1,900 square feet and the other is 1,750 square feet. So the difference between those two values is 150. So how much would their prices change? We would take that 150 times the slope and get 14.9. So they would differ in $14.9 thousand. In other words, $14,900. So when we're talking about that slope is 0.0992 for every 1 square foot increase in size the price increases by $0.099,000. So that would really be $99.